rest of the time. 0.5 is on properties of exponents, and when I say that, this section is by far the easiest section to make small mistakes on. If you thought that the other sections were hard or difficult because you were learning something new to do with these square roots and third roots and fourth roots, this section, because of all the parentheses, because of all the exponents, because of the fractions, because of the negative numbers, a lot of students make a bunch of tiny little mistakes. So what your job will be to do is you need to really make sure you remember what you're doing with your exponents. When you're multiplying the bases, you can add the exponents. When you're dividing, you can subtract. Or when you have a negative exponent, it moves it from where it is to the opposite place, like the denominator, or from the denominator to the numerator. If you have an exponent outside of parentheses, it multiplies the things inside, the exponents inside, and you would raise any coefficients to that power. So that's the first thing I start off with in your notes. The first thing I start off with is negative exponents are the opposite of factors. Instead of having that many factors multiplying each other, you're having that many factors divide each other, which is why it moves from the numerator to the denominator. Or if it's negative in the denominator, it's the reason it moves it up. Exponents only apply to the base unless there are parentheses. That's important because some students make their exponents go to the wrong things. And I'm going to explain that second point in just a second. And don't forget, order of operations states you have to deal with groups or parentheses first before multiplying or dividing. Let's do 4 examples. And I'm going to do them with you so that you have them as you start to do your homework. My first example is number 9. And there's a fractional exponent, there's a 7 outside of parentheses, there's a 3 outside, and then there's this multiplication that's happening between these two things. So the first thing I would do is I would deal with exponents outside of parentheses. I would start with this 7. And because it's outside of parentheses, there's no coefficient. I know what's going to happen with the 3 and the 7. I know what's going to happen with the 7 and the 4 sevenths. Is it going to add, subtract, multiply, or divide? Say it out loud. Good. When you times by 7, that makes 28 divided by 7. It's the same thing as 4. The y is going to be to the 21st power. You have to deal with that exponent outside first. And that goes with this 3 as well. You have to deal with this exponent first as well. That multiplies and becomes x to the 12th. The reason we're dealing with those first is because multiplication has to be done after exponents. And then once you get here, now I have x to the 4th, y to the 21st, and I'm multiplying it by 12 more factors of x. I put the x's together. We add the 12 factors and the 4 factors together to get x to the 16th. Because you're multiplying, you add the exponents. You do not distribute because there's no plus sign or minus sign. Now that you have that, let's look at number 12. I see one pair or one exponent outside of parentheses. I have to deal with this 3 and this negative mn first. This negative that's there, I'm going to write out 3 groups of these. Just write down here, negative mn times another negative mn times another negative mn, just so you know what it means. I know that a negative times a negative times a negative, negative times a negative is a positive, times a negative is a negative. I know that this denominator, this piece is going to become negative. I'm just going to write it down right there. M to the third, N to the third. I'll put parentheses, and I'm going to cross that off and that off. So I know that this is in that same spot. Now I have groups of multiplication. And whenever I have groups of multiplication, I just do things kind of top and bottom and left to right. I have a 4 times 3. I put 12. M squared, n to the 5th. And this denominator, I have a 2 times a negative. I have m to the negative 3 and m to the positive 3. But since I'm multiplying, I'm going to add my exponents. M to the 0 power just makes 1. If you want, you can write m to the 0, but I'm just going to go like this, makes 1, and negative 2 times 1 means that it's going to just go away. N to the third. Almost done. Now I'm going to simplify. You have a question about that.
How did you get negative 2 again?
How did I get negative 2? Don't forget that in here where this was, I simplified it to this. There's a negative invisible negative 1 that has to multiply that 2. So this times that made the negative 2. And now I'm going to reduce the coefficients. Negative 2 goes into 12 6 times. I have m squared in the numerator. And because I have 3 factors of n down here and 5 factors of n up there, I could subtract 5 minus 3. Or I can just reduce 3 of them with 5 and know that there's n squared in the numerator. There is nothing else in the denominator. I do not need to write over 1. And I go from there.
Wouldn't the 6 be negative?
Wouldn't the 6 be negative? Yes, it would be. Thank you. Negative 2 goes into positive 12, negative 6 times. Thank you. Last 2 examples. I have 14 and 15. 14 looks like this, a lot smaller. I can think of this that there are 4 groups of 3m times 3m, or 3 to the 4th times m to the 4th. Some people will leave this down here. Some people will put that negative 2 right there, 6 to the negative 2 and m to the negative 2. What I like to do, I hate to say it, when I have a group to a negative exponent, I like to move it up first. That's just me. It becomes 6m to the positive 2 in the numerator. And then 3 to the 4th, m to the 4th times 6 squared times m squared. Numbers are kind of big, so I'm going to get my calculator out. I think 3 to the 4th is 81. And I think times by 6 squared, which is 36, that comes out to 576 for these things. How many factors of m? I have 6 of them. You could have done that in a different way, of course. But as long as you simplify, you should get the same answer. Yes, sir.
But anytime there's a negative exponent, you can just move it to the top. Make it positive.
This group, it moves it from the denominator to the numerator or vice versa, from the numerator to the denominator. It just depends where it is at the time. Since this is in the denominator, I can move it and it becomes positive in the numerator. It does. It's the opposite. Colby.
3 to the power of 4 times 6 cubed, I got 2,960.
Try 6 squared, because I think that's 6 squared.
Oh, I
To
meant
the,
6 squared, sorry.
try that one. See if you get 576.
Yeah.
Okay. Last one. 15. As I said before when we were starting, when you look at number 15, there's lots of different places, negatives and numbers and coefficients and things where you could get tripped up or make small mistakes. So our job is to just really stay organized, have a lot of space when you're working so that you don't try to make everything so small and get lost in your own work. One of the first things I'm going to do is I'm going to deal with the things outside of parentheses. I know this -2. I could move the whole group to the bottom if I wanted to, but because there's some negatives inside, I'm just going to put this -2 on each number inside. 4 to the -2, it's an exponent. It has to stay an exponent, by the way. The a is going to be to the -8th. It multiplies. And the g is going to be a +6. Exponents never multiply numbers. They only multiply exponents. 2 to the 3rd power. A to the -9th power. G to the 12th power. Now that I have that, I'm going to move any negative exponents to the opposite place that they're in. I'm only going to move a to the -9 up here. Because then I can put them together. I think I'm ready to simplify. Let's go with it. Because I have 9 of these up here and they're positive and I have -8, I know that those, when I combine them, will be adding the exponents. 9 take away 8 leaves me with a to the 1st power in my numerator. In my denominator, I have 4 squared, which is 16, times 2 to the 3rd, which is 8. 16 times 8 is 128. And then I have to deal with the 6 g's, 6 factors of g here, and the 12 factors of g there. If I think about it, I could subtract. Or I can just go, there's 6 of these here. I'm going to be left with g to the 6th in the denominator. When you subtract 6 minus 12, you get -6, which means you have g to the +6 in the denominator. I'm going to stop your notes right there.